Okay, let's see if I can reconstruct what chapter 3 was about. Matter waves from my notes. Atoms and the structure and electrons, protons, neutrons, orbits, Rutherford, Bohr. So it's about the atom and its internal structure and especially the electrons. How are they? Where are they and what are they doing inside of the atom? And Rutherford and Bohr contributed to the internal structure of the atom. So the atom and its structure. Then about radioactivity, that was Rutherford. The size of the atom, orbits, and momentum quantization. I thought a little bit about this momentum quantization. The thing about momentum is it's usually continuous, but this tells us that only certain momenta are allowed inside of the atom. The electrons can't move at any speed. It's there's definite speeds or momenta. This is my own notes. I should know what ES is for. Electronic structure, I don't know. Force, acceleration. Oh, it's electrostatic. So they want to know how are the electrons moving, and Maxwell's electromagnetic waves and accelerating electrons will lose energy. So that way of approaching it didn't work. And then the emission of light, the spectral lines, atomic spectral lines, and Niels Bohr proposed a theory for how the orbits of the electrons can be configured to explain the atomic spectral lines. So it's the internal structure of the atom, especially the electrons. What are they doing, and how come they are responsible for the atomic spectral lines. Electron stable orbits, Niels Bohr model of the atom, and angular momentum. Angular momentum is about rotation. I'm not going to talk more about that, although I know a little bit about that. But it's very strange that it's integral values of the Planck constant. I mean, that's a linear equation. And it just steps in linear quantities up. But that's the angular momentum, of course. It's not the energy or the distances of the orbits, how they spaced. It's just the angular momentum that goes up in integral steps of Planck's constant. Okay, so it's momentum or angular momentum is quantized, orbit is quantized, not any orbit is allowed. There's specific orbits. Then the energy. They talk of the energy levels here. We measure that energy in electron volt. That's the kinetic energy, I think. The electron attains when it's moving through a potential difference of 1 volt. Gains a certain amount of energy. Electron transitions between the various energy levels. So the quantization comes in the orbits. The orbits are quantized. Electronic cells. It's actually, so they talk about shells because it's 3-dimensional structures. And then what happens when ionization of the atom occurs, the electron is freed, it escapes from orbit. Electromagnetic field, electrons, electron mass, EM page, EM field, EM page 48. Things get a bit hairy, not sure what the author is trying to convey there. It's probably just at that stage everyone was trying to contribute and what they thought about the atom and the emission of the light and whatever. So I'm not sure. Electronic structure, relativity, speed and mass. Again, I think this approaching it this way didn't pan out. Relativity. Then mass relativity and speed relativity and the size of the atom. So the behavior of the electrons differ depending on whether they're inside or outside of the atom. Inside, it's not like behavior outside. Outside, you've got current and electromagnetic fields. If you've got current, you've got magnetic fields. And then you get an electromagnetic field generated. I can't remember how does that happen. The EM field. I can't remember now. But anyhow, the behavior of the electrons differ inside and outside. Inside, we've got this inner quantized situation. The electron can't just go anywhere and have any angular momentum. Where are we time-wise? About 8 minutes it seems. Matter waves, then matter waves come into the picture. And light is this dual nature. It can behave like waves or like particles, packets of energy. Matter waves. Probably de Broglie. De Broglie's findings. He proposed that there's associated a wave, some wave that guides the motion of the electron, and that is the wavelength depending on its momentum. Now that looks like linear momentum. So this is linear motion. Its electron is moving at that speed. It's got that wavelength. That is the diffraction and the interference they saw from crystals with electrons. Matter had, I'm not sure what is that, had wave-like properties, has wave-like properties. Matter has wave-like properties. Or it's guided by a wave. And I think in some books they talk about pilot waves. Matter waves guide the matter. X-ray crystallography, wave nature. Oh, it's the wave nature of electrons. Quantization and matter waves. Quantized orbits, energy levels, light emissions, electrons, electronic orbits, or shells, electronic diffraction by crystal structure. That is the matter waves that can explain that. Electronic orbits, integral number of wavelengths in the orbits. It will only, the orbit will only be at the position where the matter wave can fit in that space. And that is chapter 3. Not too serious, reasonably understandable.